Hello everyone, welcome to Reactify Labs. In this video, we will talk about search indexes. Search indexes. Okay. Before this, I have made a video on Elasticsearch. So there will be a lot of things which I'll discuss here which will overlap with the things I discussed in Elasticsearch. And there will be a few things here which I discussed in Elasticsearch in very high level, which I will go into a little more detail or little more depth here. Okay. So let's see what structure we are going to follow today. First, we will talk about the introduction to search indexes. Okay. Next, we will see what are the key components of search indexes. Next, we will see the indexing process. Okay. After that, we will see query execution and optimization. Query execution and optimization. Next, we will see the challenges and considerations associated with search indexes. Okay. And then we will see the real world examples of search indexes. Okay. So yeah, now that structure is ready, let's start with the introduction. So a search index is a data structure designed to speed up data retrieval operations in a database or document collection. Okay. So it is a data structure designed to speed up what? Speed up data retrieval operations. Data retrieval operations in a database or document collection. In a database or document collection. It helps make search operations faster and more efficient by organizing data effectively. Okay. It uses two things. One is inverted index. So an inverted index is used in text-based searches to map terms to their corresponding document locations. It is essential for quickly finding documents containing specific words. I have talked about it in more detail in the Elasticsearch video. And next is bitmap index. A bitmap index represents sets of values using bitmaps, making it useful for handling categorical data. It helps in efficiently dealing with categorical data and simplifying data retrieval. Okay. Now let's talk about the components of search indexes. So what are the key components? First is indexing structure. So here comes three things: B trees, hash indexes, and specialized structures. Or like for example tries. Okay. So B trees provide efficient range queries and support for sequential access. Hash indexes enable rapid data retrieval through hashed keys, and specialized structures like trees are tailored for specific use cases, which again enhance search capabilities. Next is metadata. Metadata has again three things: document IDs, term frequencies, and positional information. So document IDs uniquely identify each document in the collection. Term frequencies capture the occurrence frequency of terms within documents, and positional information records the position of terms enabling advanced search functionality. Okay. And then scalability. Okay. It has horizontal scaling and vertical scaling. So horizontal scaling distributes the index across multiple nodes for handling larger data sets, and vertical scaling enhances performance by adding resources to a single node, accommodating increased query loads. Okay. Next, let's talk about the indexing process. Indexing process. First is tokenization. So tokenization is a critical process in search indexing where text is broken down into distinct tokens or terms. This step lays the foundation for constructing the inverted index. Next, stemming and lemmatization. I have talked about it in the earlier video as well. So stemming and lemmatization are crucial techniques that simplify words to their base or root forms. These linguistic processes broaden the search scope by accounting for variation in words. They ensure a more comprehensive and accurate retrieval of relevant information. So, if we take the example of stemming, so for if the word is, let's say, running, stemming makes it run. If the word is jumps, stemming makes it jump. Okay. And lemmatization, what it does is, if the word is better, it will make it good. If the word is meeting, it will make it meet. Like basically it will turn it to the root form, like the V1 form. Okay. And here what it does is it will just slash the ending part. Okay. As I told you in the earlier video also, let's say if there was something called runner, the stemming will make this also as run, which is not right because runner is not a verb. You cannot make it a base form, right? Similarly, if let's say there is a word better, for this it will still be better. Okay, because there is no base form for better, like smaller than this, so it will not change it. But lemmatization will make it its base form. Okay. And yeah, here again, if we take the example of runner here, lemmatization will not change it because it knows that runner is a noun. Okay, so it will remain the same. Next, we will see index update strategies. Index update strategies. Here comes first batch updates, periodic updates in bulk, okay, which are suitable for scenarios with less frequent changes. Then incremental updates, real-time integration of small changes which ensures continuous relevance. And real-time indexing, immediate incorporation of changes as they occur, maintaining up to the moment accuracy. Okay. Next, let's see query execution and optimization. Query execution and optimization. In the world of search engines, the main goal is to use indexes accurately to quickly find documents that match user queries. This ensures a smooth and fast search experience. Okay, so there are different optimization techniques that are used. So first is caching. So storing frequently accessed data strategically for quick future access, which helps speed up searches. Next is query rewriting. Query rewriting. Rearranging queries cleverly to make them more efficient, resulting in faster and more accurate results. And query expansion. Adding related terms to queries to improve search results and thus making them more comprehensive comes under query expansion. Okay. Next, in the same query execution and optimization, let's talk about TF-IDF and relevance scoring. TF-IDF and relevance scoring. In the last video, I told you like you don't need to know these things in more detail, and I explained why. Yes, I am not going to explain them in more detail. I will just give you an overview of this. So TF-IDF is a statistical measure used in information retrieval. Okay, TF-IDF is basically, TF stands for term frequency and IDF stands for inverse document frequency. Okay. So TF-IDF is a statistical measure used in information retrieval and text mining to evaluate the importance of a word in a document within a collection. It calculates a numerical value that represents the relevance of a term in a specified document compared to its frequency across all the documents in the collection. For example, consider a document collection containing various articles about animals. Okay, the term lion may appear frequently in a document about lions, but less frequently in other documents. TF-IDF helps identify that lion is a significant term in the document about lions compared to its occurrence in other articles about different animals. Okay, so let's say there is a book on lions and there is a book on deers. So what happens is, in the book about deers, there will be some statements like the deer sometimes get eaten by lions, right? Still there is a mention of lion. But in the book about lions, there will be a lot of mention about lions. So TF-IDF basically gives you a formula or a method to calculate what is the relevance of a particular term with a particular document. Okay. So then it will tell you that yes, lion is more relevant to the book about lions than it is in the book about deers. Okay. Next is relevance scoring. Relevance scoring is the process of assigning a numerical score to a document based on its relevance to a specific query or topic. In search engines, relevance scoring helps rank search results based on how well they match the user's query. For example, when a user searches for best smartphones, a search engine uses relevance scoring to rank smartphones based on their relevance to the query. Smartphones with more mentions of best and smartphones in their descriptions are likely to receive higher relevance scores and appear higher in search results. Okay. Next, let's see in the same query execution and optimization, vector space model. Vector space model. So vector space model has, first thing is vector representation. Vector representation. So documents and queries are represented as vectors in a multidimensional space, allowing for efficient comparison and ranking based on similarity. Next is cosine similarity. Used to measure the cosine of the angle between two vectors, determining how similar they are. It aids in ranking documents by relevance. I am not going to talk about the formula to calculate the cosine similarity because it's not required here. Okay. So in the vector space model, there are two things: vector representation of the documents and queries and the cosine similarity to find the angle between two vectors. So basically it's the similar thing in the vectors, right? So the less the angle between them, it means the more the value of cosine, and it means the more similar two things are. Okay. Next is semantic search and NLP. Semantic search and NLP. So semantic search goes beyond keyword matching, understanding the intent and contextual meaning of search queries for accurate results. And incorporating NLP techniques enhances the search experience by interpreting and responding to natural language queries more effectively. Okay, now let's talk about the challenges and considerations associated with search indexes. Challenges and considerations. So first is scalability challenges. As systems grow, they face challenges in handling vast amounts of data. Distributing indexes across multiple nodes and maintaining consistent performance. This requires strategic solutions and careful planning to ensure that scalability is managed effectively. Next is maintenance overhead. Maintenance overhead. Keeping indexes up to date in real-time systems requires ongoing maintenance. This involves ensuring that indexes remain current and relevant, which can be challenging in dynamic environments where data is constantly changing. And next is query complexity. Complex queries can impact search performance. To address this, strategies for optimizing search algorithms are essential. These strategies help improve efficiency in handling complex queries, ensuring that search results are delivered quickly and accurately. Okay. Now let's talk about the real world applications. Real world applications. First is web search engines. Search indexes power popular search engines like Google, Bing, and Yahoo. For example, Google's search index contains billions of web pages, which allows users to find relevant information quickly by searching just for keywords. Next is e-commerce platforms. E-commerce giants like Amazon and eBay utilize search indexes to enable users to search for products based on various criteria such as price, brand, and category. For instance, when a user searches for a laptop on Amazon, the search index quickly retrieves relevant laptop listings from its database. And next is document management systems. Document management systems. Document management systems like Microsoft SharePoint and Alfresco use search indexes to help users find documents stored within the system. For example, a user in a large organization can search for a specific document by entering keywords related to the document's content or title, and the search index will retrieve relevant documents efficiently. Okay. So yeah, this concludes the video on search indexes. I hope this gives you a good idea about search indexes and how they make our queries efficient. Now if let's say somebody asks you to make a system design of Google or anything, and you design a search service, then if there is a follow-up question, then you can talk about how search indexes uh, speed up your queries. And it can be different systems, like if you are asked to design a uh, Google search. Okay. Or let's say if you are asked to design YouTube or Facebook or Instagram or Spotify, anything, all of these use search, right? To search for a song or to search for any person, your friend, or post reels, a lot of things. Everything uses search indexes. So if you decide to like for example in the Instagram, if you decide that okay, there will be a search service, and then you can talk about how this search service utilizes search indexes and how using search index makes your job easier. Okay. Or actually how utilizing search indexes makes your system great by enhancing the user experience. Okay. So that's all for this video. Thank you for watching. Please remember to like, share, and subscribe. I will see you in the next one.